Okay, just for some extra practice, I'm going to let you write these down and try them, and then you can unpause the video and check your answers. Okay, so now you can pause it and check your answers before we move on, and then we're just going to go ahead and move to the next section. Alright, so what we're going to do is we're going to practice labeling angles and standard positions without converting to degrees. So we always have that tool to be able to convert back and forth to degrees, but specifically for the sake of the next lesson teaching you the unit circle, I'm going to ask you to not necessarily convert to degrees, although we know that's probably the easier way and the way you'll default to eventually. But let's say we have this circle, and all the way around is how many radians? First of all, let's do what's comfortable. How many degrees? 360, right? So then how many is radians? 2 pi. Good. So if we know all the way around is 2 pi, okay, but I ask you that I specifically want you to cut this thing into, divide into 8 equal parts. So our task is, let's write, divide into 8 equal parts. We're going to practice with radian measure. Okay, so what would I do there? What would I do with 2 pi? Divide by 8, or that's the same thing as multiplying by 1/8. So I'm going to say divide this by 8. So how much does each part equal? That reduces to pi 4. So each of the 8 parts is going to be pi 4. So first of all, here's 1, 2, 3, 4, 5, 6, 7, 8. So we've kind of sketched out 8 portions, and we said that all the way around was 2 pi, and we divided it into 8 pieces, so each of the pieces are going to be pi 4. So this one is 1 pi 4ths, 2 pi 4ths. Now we're going to go back and clean this up as we go, but I want you to see it. 3 pi 4ths, 4 pi 4ths, 5 pi 4ths, 6 pi 4ths, 7 pi 4ths, and 8 pi 4ths. Now, what do you see about that? What do you notice? What can we do to make this a little bit more simplified? You reduce anything that can be reduced. So what does this 2 pi 4ths reduce to? Pi over 2, right? Okay, so we have 3 pi over 4 is fine, but what about 4 pi over 4? Just, it's going to simplify to pi. And then this one is going to be 3 pi over 2, and this one is just going to be 2 pi, or it's equivalent to 0 as well, because we started at 0. Okay, so what happens, good, let me just check what if I ask you about where is 9 pi 4ths by chance? What would you say? Well, we started here, and we started going all the way around, and that was like pi 4ths, 2 pi 4ths, 3, 4, 5, 6, 7, 8. Where would 9 pi 4ths put us? One more, right? So, yeah, right, that would be 9 pi 4ths. Good, so you would just keep going, and it would just keep counting, like all the way around, all the way around. All right, let me see if I can erase that. Good. What about, what about if theta was equal to negative 3 pi 4ths? Where would that put us? Now recall, negative have a clockwise rotation. So if I went negative pi 4ths, negative 2 pi 4ths, negative 3 pi 4ths, that puts us over here, right? So that would be negative 3 pi 4ths. That's a bad angle. There you go. Roughly. Anyway, that's just an FYI as we continue to do a little bit more of these. Just some practice with radian. Alright, the next thing I want you to do is a similar task. This time I want you to take this, and your task is to divide it into 12 equal parts. So I want you to try this one by yourself and see how you do. Okay, so this is 12 equal tick marks all the way around, and so if we take the entire circle, which is 2 pi, and divide it into 12 pieces, then each part is going to be pi 6. So let's go. Let me get a different color. So this is 1 pi 6, 2 pi 6. You may reduce these as you go, but just for the simplicity of it, this time I'm not. 3 pi 6, 4 pi 6, 5 pi over 6, and continue all the way around. Okay, and check those. So we just 7, 8, 9, 10, 11, 12. Now go back and simplify if you didn't do that already. Simplify any fraction. Okay, so the next thing we're going to look at is coterminal angles. Basically, two angles with the same initial and same terminal side. And like we did that one when I just threw an example out to a minute ago when we did 9 pi 4s. But let's look at coterminal. If I give you the angle 4 pi over 3, just to give you another example. 4 pi over 3 is coterminal with 16 pi over 3. Okay, so let's go see how that would work. Let's actually count that out on the previous page. So, 4 pi over 3 was right here. Okay, and let's take our 16 pi over 3, which if I divided that out, how many times does 3 go into 16? 5 times, which accounts for how many of them? 3 times 5 is 15. How many are left over? 1. So wouldn't that get me the same thing as this, right? 5 pi plus pi over 3, because 5 times 3 is 15. That would account for 15 of them. I would need one more pi over 3. So basically that would take us around 5 pi times. So 1, 2, 3, 4, 5, and then another pi third. So we could put it right here. Coterminal is where it starts and stops. So my initial side and the terminal side land in the same place. So basically 4 pi over 3 and 16 pi over 3. So from the last page, 4 pi over 3 and 16 pi over 3 are coterminal because their initial sides are the same and their terminal sides are the same. Now, what's the only difference between this one and this one? Is it goes around more and more revolutions, right? But they always start and stop in the same location. So initial side and terminal sides will always match up. This is kind of like a multiple of other in terms of revolutions. Okay. Alright, just for extra practice and a bit easier one to see, 11 pi 4. So I want you to think for a minute and tell me which one of these you think would be coterminal with 11 pi 4s. So even if we just started and redundantly counted around 1 pi 4s, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi 4s would then put us over here. It's coterminal to 3 pi 4s. So these two are coterminal. Okay, let's practice with a few of these. Find a positive angle less than 360 or 2 pi that's coterminal with the given. If it gives you the information in degrees, your answer can be in degrees. If it gives it in radians, answer in radians. Okay, so what degree is coterminal with 450? How do you think we would do that? Take out one whole revolution all the way around in degrees. How many is that? 360. And where do we land? Good. So 450 is coterminal with 90 degrees. All right. What about negative 79? First of all, negative 79, remember we would go in the opposite direction. So instead of subtracting 360, what do? Good. We're going in the other direction, so we're adding 360, and that would put us at 281 degrees. So negative 79 is coterminal with 281. Alright, this time we're going to be dealing with radians, so we want to answer in radians. If I am at 10 pi over 3, okay, and I wanted to take out a whole revolution all the way around, what would I take out in radians? Yeah, good. So I would take out 2 pi. Subtract out 2 pi. Now I'll write this out. You would need a common denominator. 10 pi over 3 minus 6 pi over 3. Get a common denominator there, and then just subtract that. So we would say 10 pi over 3 and 4 pi over 3 are coterminal. They start the same initial position and terminate in the same position. Alright? And the idea of if it's a negative radian, instead of subtracting 2 pi, what do? Good. Add 2 pi. Common denominator, and then simplify that. Okay, finish out those last ones, and then we're going to remember that arc length from before, the formula you had before is that theta is equal to S over R. So if you solve that for S, mean multiply both sides by R algebraically, then we just know the formula for arc length is S is equal to R divided by theta. So this is your new formula that you want to know, and this is for theta in radians. Okay, we want to find S, but we know for theta is in radians. So first of all, this is our given information in a picture. Theta is not in radians, so take a minute and convert it to radians. Okay, good. Multiply by pi over 80, and this is our radian measure that's equivalent to 50 degrees. Now we just need to plug it into this formula over here. So the radius is 8 because it's given in the problem, and our theta in radians is 5 pi over 18. And we solve for S just by simplifying the right hand side, and then we can put that in the calculator and we'll get approximately 6.98 meters. So that's saying the arc length S here to here is approximately 6.98.